Today we're going to look at the area of a trapezium. So here is an example of a trapezium. Now what defines a trapezium is the fact that you've got two parallel sides here. And that's basically it. So fun facts, a square is actually an example of a trapezium because it has a pair of parallel sides here. It just happens in the square's case that these two are also parallel and they're all the same length. A parallelogram is an example of a trapezium. In this case, we have a pair of parallel sides like that. For a parallelogram, it just happens that we've got another pair of parallel sides. So don't think that a shape just has to be one type. Having said that, this is kind of the accepted look of what a trapezium looks like. So once we've got our parallel sides, we tend to then have it coming off from an angle and then some other angle that's a bit like so. But you know, if we were to have a trapezium, like if this was my trapezium, that would be absolutely fine. You know, it's going inwards, and also if it went sort of straight down, you know, this is another sort of classic kind of trapezium actually that you will see, and you will need to use the trapezium formula for. I'd say just in this case, you can actually split it into a triangle and a rectangle. It's a bit easier. Okay, one other thing I was going to say is there's one special type of trapezium. Just going to mention it. If this side comes down like this, and these two are the same length, then it's called an isosceles trapezium. Just like an isosceles triangle has these two lengths equal, or it doesn't have to be those two lengths, it could be those two lengths. But anyway, this is a word we use for it. So I just want to talk a bit about trapezia, that's the plural for trapezium, before I went on to calculating the area. So how can we calculate the area for this? Well, we need to assume that we know the base, which I'm going to call B, the heights, sometimes called the perpendicular heights, and then this length here, which is kind of the top. We don't call it T there, we use A for it. How can I calculate the area of this thing if I know A, B, and H? I can't quite easily like divide it up into triangles and rectangles because, you know, I don't know what this length is then, and I don't know what this length. It's all a bit confusing. So what we can do is an amazing little trick actually. We can generate a formula by doing a bit of magic actually. And my bit of magic is that I am gonna go abracadabra, and I've created a second trapezium that is exactly the same. That was pretty cool, wasn't it? How does that help? Well, check this out. I am gonna rotate it. Hocus pocus. And I've got an upside down trapezium now. How does that help? Well, look at this. I can join it up like so, and check it out. This line here is parallel to this line here. It has to be. I've just rotated it through 180 degrees. And then this, more importantly, this line on the right is parallel to this one on the left. So I can now, as well as I've got like these parallel lines, I've got these two as parallel. What shape does that remind you of? Parallelogram, is that what you're thinking? I hope so. So we recently looked at the area of a parallelogram, and we said it was just the base times the height. So let's imagine I've got the height, I know what that is. We said before that this length was B and this length was A. Okay, but that's going to mean that this length is also B and this length is also A. So we can write down the area of this parallelogram as the base, which is now A plus B times the height. That's the area of my parallelogram that I've made. I don't want the area of the parallelogram made. I want the area of the original trapezium. I've got two lots of the trapezium, so what can I do? I can have this larger area, and that will give me the area of my trapezium. And this is the formula for the area of a trapezium. Now, if you forget it, well, you could get your trapezium and you could like double it. You could imagine making two of them, draw them next to each other, and kind of generate the formula yourself through parallelogram. But I would advise you try and learn this formula along with the ones for rectangle, parallelogram. It's the same. Obviously, circles in there, and now we've got trapezium. So this is a little summary of what I've just said. I've said it can be copied, rotated, connected to the original trapezium, this top one to make this bottom one, and then I've got a parallelogram, base a plus b, so I can a plus b times height to get the area, but I'm going to need to halve it. Okay, so we're now basically going to assume we know this formula, and we're going to practice applying it. So please make a note of this. Really important. Okay, let's do some examples of it in action. So every time you do a question like this, what I want to see is you labeling the sides. I've got the wrong, no, I've got the right pen. Okay, so this is A and this is B. If you do it the other way around, actually that's okay, but I think a good idea is to make A the shorter side and B the longer side. And then this is going to be our height. So if I want the area, it's going to be a half times A plus B, which is 9 plus 15, and then I'm going to times that by 8. And now I can work this out. I can do a half. By the way, this is a times in there, half, and then I'm going to add these together. So when you have brackets, you have to do that first. It means like you must add these, you must do whatever's in the brackets first before you do the other stuff. That's like a rule of maths, basically. We're going to do 9 plus 15. That's going to give us 24. Actually, you can just stick all of this in your calculator. I'll show you about that in a minute. And then I have to have either the 8 or the 24. I think I'll have the 24. So that'll give me 12 times 8, and that is equal to 96. But it's not just 96, it's 96 centimeters squared. So that could be how you do it without a calculator. Just going to load up my calculator, just bear with me, okay? No, I don't want to activate my license right now. Here we go. So if I wanted to work this out, I could do it like this. I could get the fraction button, then do 1 over 2, press right, then do times, and then get my brackets, 9 plus 15, close brackets, and then multiply by 8. Although algebraically, sometimes we don't worry about putting like times in, I think it's a good idea when you're using a calculator to stick them in. And we press equals, we get 96, which is what I got before. Brilliant. Just wanted to demonstrate that, how you can do it with your calculator. Okay, let's do the second example. This time we've got a trapezium. It's one of these funny ones where actually the line is just coming straight down. And like I said, you could split it into a triangle and a rectangle and find them individually and add them together. That's fine. I'm going to do it without. Now I know it's been rotated, but that's okay. I'm going to always look at the parallel sides. That's these two, and then this one on the left is A, and this one on the right is B. Don't go making that 7 equal to B, because I don't have a parallel line up here to link to it. So actually this one is the height. If I want the area, I'm going to come up here and do it. The area is going to be a half times 10 plus 12 times 7. That's going to be a half times 22 times 7. I'm now going to find half of 22. That's 11. 11 times 7, which is 77 centimeters squared. So that is the area of this trapezium here. Okay, one more. This is like the strangest looking trapezium, but I did talk about this. I said it doesn't have to kind of come down like this. It can go back on ourselves. The definition of a trapezium is just that I've got my two parallel sides. So here, let's call this one A because it's the shorter one, and this one B. It doesn't matter if you do it the other way around. This is my H, and then the area is going to be a half times 4 plus 9 times 5. Okay, that's going to be a half. Oh, this is looking a bit awkward. Half times 13 times 5. Now, it's not so easy now because I've got an odd number. But half of 13 is actually 6.5. And then I'm going to do 6.5 times 5. You might want to get your calculator out for this, but 6 times 5 is 30, and 0.5 times 5 is 2.5, so this is going to be 32.5. Again, it's centimeters squared. What other questions for trapeziums could you get? Well, I might give you the area and ask you to work out one of the missing lengths. I'm not going to do an example on that. That's a bit of an extension question, but be aware. You could get compound shaped questions. So I might say, like, what is the area of if I color that in blue, what's the area of this green region? Then you'd have to find the area of the whole thing and subtract the square. I would have to give you the dimensions of the square. That's the sort of thing. Another thing, actually, this last little thing to mention, is that maybe I give you different units. I might say that this is 4 meters, and then you'd have to convert it to centimeters first. So just giving you a little heads up on the other things. But as long as you've got the basic idea of how you can use the formula, and you can apply your other knowledge of mathematics, and you're in a good place for your area of trapezium. Hope that makes sense. Practice.